I hope you're comfortable. At least I am. I'm interested to hear where you're all from. Emirates? Anyone? Emirates? Anyone from Emirates? No? How about Portugal? Anybody from Portugal? There we got the guys from Portugal. Flanders, anyone? I know you're from Flanders, all right. Anyway, my name is Geoffrey Ejzenberg. I come from Flanders in Belgium, a very small country, better known for its chocolate and waffles. As a safety briefing, I hope nobody will come on stage and slap me like Will Smith did, but when I say that Autonomous Night enables the future of autonomous transportation with our patented multispectral sensor system, creating superhuman vision. And here it is, the Autonomous Night long-range electro-optical unit, or, well, I know, it's how the design looks. This sensor enables us to fast-track autonomy levels in any transportation mode, be it on land, water, rail, or in the sky. But before we get into this, let's take it a step back. I often ask myself, where is the future of transportation going? Maybe this? Wouldn't it be cool if this would be possible today, right? Teleportation as the ultimate mode of transportation, as in Star Trek, seems a bit complicated to enable today. So for now, my team and I, we're focusing on solving the challenges of real autonomous transportation. So when we talk about autonomous, what is it really? And what is everybody trying to do when making cars, drones, trains, and ships autonomous? And basically, we're all trying to mimic human behavior, and if possible, to outperform how we humans execute certain tasks. So it should not come as a surprise that if you want to autonomate, and let me repeat that for you guys, autonomate, so not automate, a vehicle, a machine, or anything else, it starts with how good you can see or perceive the world we live in. Because no matter how smart your brain is, if your eyes are blind, you will not see a thing. This is no different for machines. If the sensors of your vehicle or machine cannot see adequately in all weather conditions, day and night, then it simply doesn't work. So no matter how much AI you will throw at it, you will still not be able to see and understand the world this vehicle or machine operates in. When you can see and identify objects that you are confronted with, only then you can understand the situation you are in. And how you should interact with these. And this cycle goes on and on and on, faster than the speed of light, between our eyes, our brain, the nervous system, all the way down to our hands or feet, and all the way back to the brain. But it's clear that it starts with the eyes, because the eyes, they identify objects, or at least that's how it should be. So why do I say should be? A couple of weeks ago, I was invited to a presentation of this thing here. Does anybody know what this is? Nobody? This is an autonomous vessel called the Mayflower. Similar like the Pilgrims in earlier days, this vessel left from Plymouth in England and was supposed to cross the Atlantic autonomously to Plymouth in the United States. At a certain moment, the engineers on shore could not believe their eyes when the monitor showed that the ship was going backwards. And they thought it was a malfunction. But after double checking, it was indeed the case. The ship was going backwards. So the reason why it was doing this was because it was avoiding a collision with an object it had detected coming towards it. So what was this object? Was it an island? No, it wasn't. Maybe it was a floating container. Nope, that wasn't it. Or maybe it was an iceberg. Still no. The object it had detected but was unable to identify and therefore understand and know how to interact with it was a group of dolphins. So what have we determined so far? First, that we all understand the difference between and the impact of identification versus detection. And second, the importance of fast identification from mimicking the human neural network. And last but not least, the need for reliability and accuracy to execute this task in all situations and weather conditions. Now, how can we make this incredibly difficult task possible? There are really only two dominant strategies or philosophies for object identification. And here is one of them. Anybody knows what this is? Not everybody together? This is LiDAR. And LiDAR sends out a laser to detect and measure the distance of objects. And this is a point cloud generated by a LiDAR in good weather conditions. But guess what happens in less than ideal weather conditions? In human context, it is the same as how a person with glasses would see in the rain. And this laser also captures the raindrops, the snowflakes, the droplets in fog, or even dust particles such as in sandstorms, which we all know from here, which makes it absolutely useless. So no matter how much time, energy-consuming AI, and processing power you will throw at this technology, it remains inherently flawed. And moreover, LiDAR has a physics-constrained problem that cannot be solved ever. And then there's the challenger philosophy embodied by this guy, Elon Musk. I may not agree with all he does or says, but I'm sure that he's gonna love our solution when he sees it. Because also he believes in the claim that cameras, similar to the human eye, should do the trick. And frankly, if 800 companies have spent more than $3 billion on LiDAR without coming with a silver bullet solution, then maybe, just maybe, we need to revisit the choice of the technology to start with. And that's exactly what Autonomous Night is doing. We have mimicked and improved the capabilities of the human eye by creating a multispectral camera system. We developed and patented the best mid to long range sensor enabling superhuman vision that will fast-track transportation autonomy levels and enable the future of autonomous transportation. We call this the AKLEOU. I know it sounds weird, but let me repeat that for you. It's AKLEOU. And this stands for the Autonomous Night Electro-Optical Unit. So what is it really? It's a multispectral camera that performs in all weather conditions, day and night. It's on one single optical axis, and in human language, this means that unlike all our competitors, we don't have to do sensor fusion by software. So no processing power or energy or time loss, making it ideal for real-time, high-speed applications. Well, I won't bother you with this third one, but my co-founder, who's over there, and my CTO, Noel Jans, he will gladly explain you what this really means, but it's going to cost you a couple of drinks. And lastly, because we can tailor the design to the application, it can really be used on land, water, rail, and in the air. And indeed, we will replace LiDAR, but the really huge value upswing is when we monetize this image data that we capture to recreate the world in 3D models for geospatial mapping applications. Our multispectral data set holds so much more valuable information than a regular camera, let alone a lighter point cloud. So much more value potential that DXC Technology and IBM were really quick to partner up with us to explore these data monetization possibilities. So, who are we to make this happen? We're a multi-skilled, knowledgeable, and complementary team of professionals with decades of experience in designing and implementing electro-optical systems for space and defense applications, such as the photonics aboard of the 2 satellites currently in orbit measuring the solar intensity, as well as the night vision goggles for various countries. We are supported by a high-caliber advisory board, and we've been working together as a team for more than 5 years on autonomy projects, such as in the mining industry, and this is really where we came up with this idea. We were asked to make a mining vehicle autonomous because trucks running into things or running over people, that's a problem. This is where we understood the unmet challenge encountered by applications where LiDAR is being used as a mid to long range sensor. Today, there is no sensor available that makes 24/7, 365 autonomous transportation possible. They all fail at identifying what is known in the industry as their smallest mission-critical object and succeeding in doing this in any weather condition, day and night. In this specific mining use case, the smallest mission-critical object was a person. I'm not going to name where it was, but they didn't really care too much about running over a wild dog or a kangaroo, but running over a human is a problem. And the current sensor systems equipped on these behemoth trucks, they can only identify an object, being a person, at a distance of 18 meters, 1/8. While the regulations stipulate that these trucks must be able to perform an emergency stop within 50 meters. I don't know about you, but I wouldn't want to be anywhere near these trucks today. Our sensor provides these vehicles with an identification performance exceeding 200 meters in any weather condition, day and night, with the ability to monetize the imagery for high value and impact applications such as predictive whole road maintenance. The challenges faced by these mining vehicles are also encountered in each industry that uses LiDAR as their long-range sensor in 24/7 real-time transportation, such as our cars and trucks, but also ships, trains, and UAVs, and planes, and anything on rail, really. The combined automation potential exceeds 180 billion annually, of which we aim to take 2 billion market share. Our multispectral images provide a unique value for the geospatial mapping industry, which is set to exceed the potential of all our autonomous markets combined. Well, we cannot change an industry or an economy by ourselves alone. We know very well what we're good at, but we know even better at what we suck. And that's why we got partners, and here are a couple of them. We are particularly proud of the support of the European Agency for Innovation and Technology and our enabling technology partners such as DXC Technology and IBM. So where are we today and what do we need? First, well, we recently signed an LOI with an Irish industrial automation company for the first 200 units. Our technology is patented. We've been awarded with a grant from the Belgian government for about $350,000. We've been voted one of the top 500 European companies for impact mobility. And the reason why we can be here with you today is because we recently won the EIT Urban Mobility Investment Readiness Program that came with, well, an expenses paid trip to beautiful Dubai and this amazing World Expo. And last but not least, this speaking opportunity here at the IM. We're currently raising our seed round for 1.2 million euros, but it's closing fast, so if you want to get on board, the time is now. So why invest in us? Well, we have a stellar team with patented technology, a very large market potential with huge upswing possibilities. And where together with us, you can really make an impact within the sustainable and autonomous transportation. So what do you need to remember about autonomous night? Our sensor will enable real autonomous transportation by replacing LiDAR while becoming the leading situational awareness system supplier and maybe the most valuable sensor tech company. A big shout out to my friends at the EIT Urban Mobility and Connectology, and I look forward to meeting you guys in person. If you're really interested, I invite you to join us for a drink this evening at the Belgium Pavilion rooftop terrace. The places are limited, so do check with us in advance. And if you can't join us tonight and have questions you really can't hold back, I'm all ears. Thank you very much and cheers.